In this video, I'm going to show you how the SSIS Advanced ETL Automation process works. We are starting out in the Maestro database, and the table we're going to import into the data warehouse for this demo is TBL Contracts table. As you can see, this is a fairly large table with an extreme number of data columns. First, I want to show you where the heart of the ETL process resides. It's in a set of stored procedures in the master database. The primary SPROC is named USP SSIS Automation Script. And as you can see, there are currently 10 parameter values for the stored procedure. First is origin server. This is the server name where the origin data resides. The origin database, which is what it sounds like, it's the origin database. The schema name for the table that we want to import. The actual table name from the origin database. Then the destination server, and as you can see in this demo, it's the same server as the origin server. The destination database, destination schema, destination table name. The schema name for the ETL, and you'll understand what that's for, and skip flags. I'll explain that later on. Now, when we execute the stored procedure, you'll notice the first thing the process does is gather a list of columns for the origin table. These columns are used, obviously, during the processing of the ETL process, or construction of objects, I should say. Then if you switch over to the Messages tab, you'll see some execution information that is being printed out. This is really only for troubleshooting purposes in case something unexpected happens during the process. Now, if we go back to the origin database, you will first notice that there are a couple of new tables which have been added. In this case, we have TBL Contracts Flags table, and this is basically only contains a few columns, which are the PKID identity column, the primary key for the origin table, last modified date, modified type ID, and CRM sync. The modified type ID column tells the ETL process which records have been updated since the last ETL run. The next thing you'll notice is there's a new trigger on the parent table. This trigger manages the data in the flags table structure, and it first detects the type of modification that's been made and updates the last modified date and modified type ID values. The valid values for the modified type ID column are 0 for no change, 1 for insert, 2 for update, and 3 for delete. These are important in the overall ETL structure, but they are what give the performance advantage of this processing type. The other table that's created in the origin database is the update PKs table. And this table has a single column to hold the PKID values in order to reset the processed values to 0. Now let's look at the stored procedures that have been created by the ETL automation process. First is the keys reset SPROC. Then the select modified SPROC is next, and this one really does the heavy lifting in the origin database side as it returns both the origin table and the related flags table values for all records that have been updated since the last ETL run. Then we have the keys reset SPROC, which does exactly as the name suggests and resets all of the key values for records that were successfully processed into the data warehouse. That pretty much covers the origin database. So now let's look at the data warehouse side of things. In this case, the data warehouse is named EDW. And the first thing you'll notice is that we have a DIM contracts table as well as a DIM contracts keys table. Now currently the keys table only has the SKPKID value and the primary key of the parent table.